This is the fourth lesson of topic 12. In this lesson, we are going to be looking at dilations on the coordinate grid, and we're going to be using centers of dilation that are at the origin, the point 0, 0, and at other points on the coordinate grid as well. So in this first picture we're looking at here, this is a dilation from the origin. Our center of dilation is this point O, and it is at 0, 0 on the coordinate plane. Now I can tell which one is my pre-image by looking at which one does not have that prime notation. So P is my pre-image, it's the point I'm starting with, and I'm trying to locate where P prime will be. In this example, we're using a scale factor of 3. And so in order to locate the new point, I'm going to start at my center of dilation. I highlighted that here because that's very important. You start at the center of dilation, and you're going to draw a horizontal and vertical line that would lead you to your pre-image point. So I see this is my horizontal line and my vertical line, and I can count those distances since they're horizontal and vertical. Just count those units. So the horizontal distance here is 3, the vertical distance here is 1. So I'm going to multiply those distances by my scale factor, and I would get, instead of a horizontal distance of 3, 3 times 3 is 9, and instead of vertical distance of 1, 1 times 3 is 3. So I go back at my center of dilation and go those new distances in order to locate where my image point is. So going horizontally 9 units and vertically 3 units leads me to this point P prime located at 9, 3. Now if your center of dilation is at the origin, I hope you can see that the coordinates are just being multiplied by your scale factor to get your new coordinates. 3, 1 became 9, 3. 3 times 3 is 9, 1 times 3 is 3. Now that only works when your center of dilation is the origin. And like I said, we're going to be dilating from other points today as well. Remember that your center of dilation, your pre-image point, and your image should always be collinear points. So if they are not on a line together, you definitely know you did something wrong. So question 1 says, how can you find P prime if the center of dilation is not at the origin? And so your process is really going to be the same as what we just talked about. So on number 1, the very first thing you're going to do is start at your center of dilation and draw the horizontal and vertical distances to your pre-image. That's the point you're starting with. After you have started at the center of dilation and drawn your horizontal and vertical distances to your pre-image, you're going to multiply those distances by your scale factor. Multiply the horizontal distance and the vertical distance by your scale factor. And then to locate your new point, you're going to go these new distances from your center of dilation to your new point. And we know we call that the image point. So start at your center of dilation, draw your horizontal and vertical distances to your pre-image point, and then multiply those distances by your scale factor. Go those new distances from your center of dilation, and that will locate your new point. So we are going to actually do that on number 2, practice that. So if that process doesn't quite make sense, hopefully after we do it a couple of times, that'll make more sense. So on the first one, it says to find the image of point T25, P, which is 25, under a dilation with a scale factor of 1/3 and a center of dilation of 8,2. So your first thing you want to do is go ahead and plot those points. So 2, 5 means go right 2, up 5, and that's point P, my pre-image. And then my center of dilation is at 8,2. Now, since my scale factor is 1/3, anytime your scale factor is between 0 and 1, remember that will make your points get closer to your center of dilation. So we can see where my pre-image is. I know my image point is going to be somewhere closer to the center of dilation than it was. And I know it's going to be on that line. So those are just some things to make sure that you understand. So remember, we're going to start at our center of dilation, and we're going to draw the horizontal and vertical distance to my pre-image. So horizontally, I would go this direction. Vertically, I go up, and that would lead me to point P. So I'm going to count these distances. Now, if we were doing slope, we would worry about positive and negative signs, but since we're looking at just the distances, distances are always positive. So this distance here I can simply count as 1, 2, 3, 4, 5, 6 units. And this distance here I can simply count as 1, 2, 3 units. So remember, I'm going to multiply those distances by my scale factor. So when I multiply 6 times 1/3, I get 6/3, which is 2. And when I multiply 3 times 1/3, I get 3/3, which is 1. So now we're going to go these new horizontal and vertical distances from the center of dilation. So that's really important. You don't start from the pre-image point, you start from your center of dilation. We're still going in the same directions, so we're not, when I say go horizontally, 2 units don't go to the right. The other point was to the left, so we're still going to go to the left. So we go to the left 2 units horizontally and up 1 unit, and this gives me my image point P prime, which is located at the point 6, 3. So remember, my point P was at 2, 5. I cannot just multiply that by 1/3 and find where my new point is, because my center of dilation was not at the origin. So I had to find those distances, multiply them by the scale factor, and then go those new distances from my center of dilation to locate P prime. Again, it makes sense that it is closer to the center of dilation than my original point was, because that scale factor was between 0 and 1. Okay, so let's try that again down here. So remember, we're going to begin by plotting our image point, 3, 1, or it's our pre-image, sorry, 3, 1 is point P, the pre-image at 3, 1. And our center of dilation this time is at 1, 5. So remember, that's my starting point, the center of dilation. I'm going to apply a scale factor of 1/2. So again, I know that P prime is going to be closer to the center of dilation than my pre-image point was. And so I'm going to, again, look at that horizontal and vertical distance from the center of dilation to my pre-image point. So I went to the right 1, 2 units horizontally, and I went down vertically 1, 2, 3, 4 units. So I'm going to take those distances and multiply them by my scale factor. So 2 times 1/2, of course, is 2 halves, which is 1. And then 4 times 1/2 is 2. So I'm going to go these new horizontal and vertical distances from the center of dilation. So instead of going to the right 2, I'm going to only go to the right 1 unit. And instead of going down 4, I'm only going to go down 2 units. And so this is my image point. P prime is located at 2, 3. Again, notice the collinearity of those 3 points, and that this point is closer to my center of dilation than the pre-image was. Now, since my scale factor was 1/2, what's another name for that point right there? I hope you recognize that this is really the midpoint, since my scale factor was 1/2. So we have another way that we could have found the midpoint with those 2 points, 3, 5, and 1, 5, is really just averaging your x and your y coordinates. So adding 3 and 1 and dividing by 2, and adding 1 and 5 and dividing by 2 would also give me my image point. 3 plus 1 is 4, divided by 2 is 2. 1 plus 5 is 6, divided by 2 is 3. So this was just my midpoint and a different way of finding that using a dilation. Okay, so let's look at a negative scale factor. So remember, when you have a negative scale factor, it does two things. It does the dilation, but it also does a 180-degree rotation of the points. In this case, it's just 1 point. Remember, this will also put the point on the other side of my center of dilation. So we're looking at the point 4, 8. I'm going to go ahead and plot that pre-image point P at 4, 8. We're dilating from the origin. So remember, really, all I have to do is just multiply that scale factor times your coordinates at that point and find the new point, since the center of dilation was the origin. If it was another point, I couldn't do that. So if I take 4, 8 and multiply both of those times negative 1/2, I know that my new point should end up at -2, -4. And again, you can only do that when your center of dilation is the origin. But we can go through the same process we just did and go from my center of dilation to my image point, which is 4 units horizontally to the right and 8 units vertically up. And so when I multiply those times -1/2, I find that my new horizontal distance is -4/2, which is -2, and my vertical distance is -8/2, which is -4. So that just tells me to go the other direction. Instead of going 4 units to the right horizontally, I'm going to go 2 units to the left. And then instead of going 8 units up vertically, I'm going to go 4 units down vertically. So here is my image point located at -2, -4, which I already knew it was going to be anyway. Remember, the collinearity should still be true between your pre-image, your center of dilation, and your image point. I just want to say one more time, do not multiply your scale factor times your coordinates if your center of dilation is not the origin. That will not work. It only works when your center of dilation is the origin. Okay, so the last thing we want to look at is just a puzzle that finds the midpoint, which remember is the scale factor of 1/2. And so this is my midpoint of these 2 points, and so we're seeing where these values come up from. So if I look at the horizontal points here, A is at x1, y1, and C is at x2, y1. The y's are the same because they have the same vertical distance. The horizontal distance is what changed from point to point. So you can see my midpoint is still going to be a y value of y1 because it's still the same units up as these other 2 points are. So to find the x, it's halfway between x1 and x2. So to find the halfway point, I would have to add those two numbers and divide them by 2. So the x coordinate here would be x1 plus x2 divided by 2. Looking vertically here, these all go to the right the same number of units, so you can see they all have an x of x2, just like point C did. The y value is what's changing, and this one has a y1, and this one's y2, and this one's halfway between. So again, I would have to add these y values and divide by 2 to find this new y value here. So that tells me that this point right here, the midpoint between these 2 points here, has the same x as this point does, which is x1 plus x2 divided by 2, because it goes to the right the same number of units as that point. But it has the same y as this point, because they go up the same number of units. And that is my formula for finding midpoint. Average your x's, which means add them and divide by 2. Average your y's, which means add them and divide by 2. Alright, that is it for today's lesson. A couple of things on your assignment tonight. I'll actually have to do that in the next video because I don't have enough time in this one.